Okay, so here's one last example of case 3 of partial fraction decomposition. So just another look at one in case you need a little more practice or help. So you may just want to see the setup if you're pretty confident with following through on the rest of it. Um, okay, so we look at this problem and we actually know that it's case 3 because we have x squared plus 4, and that can't be factored. Okay, unfortunately I see some people factoring it, but what you're thinking of the difference of two squares, which is a squared minus b squared, which factors as a plus b times a minus b, right? You can do the difference of two squares. If you have the sum of two squares, no, okay, you can only factor those over I, okay? No real factors. You actually can factor them over I, but we're doing real numbers here with no i's, so we're good. We're just going to keep it that way. It is a non-reducible quadratic, right? Non-reducible quadratic. X is actually the repeated linear factor. I know it's confusing, right? But you could have x times x. So those are both linear, right? So this is actually x times x. Okay, so to break this down into our pattern then, our first denominator is going to be x. That's going to be a over x. And our second denominator is going to be x squared. Remember, this is case 2. Okay, that's the pattern for that because it's a repeated linear factor. All right, then we're going to have our last term, and that is cx plus d over x squared plus 4. And that's because that is the pattern for case 3, the irreducible quadratic denominator. Ooh, I think I got all those big words correct this time. Okay, so this is how the whole problem would be simplified out, and we just have to find the a, b, c, and d. Okay, so let's see if we can do that together. Let's multiply everything by the denominator. So x squared times x squared plus 4. Okay, so our left becomes x plus 4, and our right becomes a x times x squared plus 4. Okay, plus b times x squared plus 4 plus, use a parentheses here please, cx plus d times, because all of the cx plus d, all the numerator has to be multiplied by, in this case, x squared. Okay, so let me see. Oh yeah, so I think I actually I chose to do this one using the system just because I've been doing the let x equal so many times that I thought it's good to see the system example too, just in case you prefer that. The other reason that I chose to do the system was, look at this factor, x squared plus 4. There's no number I can put in for x. So I can't do like let x equal such and such. That term isn't going to go away. So I could do let x equal 0, and then I would get rid of the a term, and I'd get rid of the c and d terms, right? And I would solve for the b term. And so I could do that. But then how do I find a, c, and d, right? So, because I don't think I can because of this x squared plus 4. I think it could be pretty tricky. Okay, so I thought let's do it the other way and review how to do that. So on this side, whoa, on the left side, I'm going to set up kind of what the identity is. So notice that this is going to be x times x squared. I think the highest is going to be x cubed over on the right. Okay, so really over here what I have is a 0x cubed and a 0x squared, and I have a 1x and a 4. Okay, I didn't change the left side. I just thought, well, 0 is the coefficient of x cubed and x squared, and really 1 is the coefficient of x, as we know. All right, now on the right, I have to do a little bit of simplifying. It's not terrible on this problem, though. So it's ax times x squared, so that's ax cubed, and ax times 4, so 4ax. And then I just distribute it here. Boop, boop. Now I'm going to distribute the b, so plus bx squared plus 4b, and then I need to distribute the x squared here. It looks like that. So that's cx cubed plus dx squared. Okay, so now to line up the terms correctly, I'm going to change the colors. So I'm going to make the x cubes be purple. Okay, so I have 0x cubed, and over here, the x cubed terms are here and here, right? I have 2 x cubed terms, so that's x cubed times a plus c. Okay, now let's use green and do 0x squared, so plus 0x squared. And so over here, let's see if I have any x squared terms. I do. Here's one, x squared, and here's one, x squared. So that's plus x squared times b plus d. Okay. Now we'll use this nice bright pink for plus 1x, so plus 1x. Let's see, here's an x term. That's not an x term, there's no x there. So I think there's just the one x term. So plus 4a times x. And then finally, what other color do I have? I guess purple here. All right, so plus 4. Okay, that's the constant term. So the only constant term I'm seeing here is the plus 4b. There's no x by it, okay? So plus 4b. Okay, I very purposely did these colors so you could see that we need to match up to create our system of equations, and I promise it won't be too hard to solve, is we need to line up that x cubed is, the coefficient is 0. So on the right, a plus c has to equal 0. So now let's use those same colors to create 4 equations. 0 equals a plus c. Okay, I left this side on the left, and then a plus c is from here. Next, in the green coefficients, x squared, the coefficient is 0, and on the right, it's b plus d. Okay, in pink, the coefficient of x is 1, and on this side, it's 4a. Oh, why do I have an x there? I don't need an x there, just 4a. Oops. Okay, and then finally in purple, the coefficient or the constant term is 4, and that has to equal 4b. Okay, so now we can see we can solve for a and b really easily. Let's see, b is equal to 1, right? And a looks like it's equal to 1/4. Okay, and then since we know a and b, we can solve for c and d super easily. Yay, I told you, once you get the system, they're very easy to solve. So I'll do a. Let's see. 0 equals 1/4 plus c. So c is 3/4. No, sorry, negative 1/4. What was I thinking? Jeez, going too quick. Negative 1/4. Okay, and then d, that's 0 equals 1 plus d, that's 0. So d is equal to negative 1. Fantastic. Okay, now I just have to find some space to write my answer. Okay, so I'm just filling in A, B, C, and D, and I'll have my solution. I think I can fit it down here. All right, so that's 1/4. That problem was almost fun. Over x plus 1 over x squared. Hope you liked it too, haha. C is negative 1/4 x plus d, so that's minus 1. And then that's over x squared plus 4. Yay. Okay.